Hello students, in this video we'll introduce the idea of hypothesis testing. So if we're given a hypothesis that we wish to test, given some data or events which follow a distribution, okay, we call this hypothesis test. Okay, well, let me do this through an example. Okay, so suppose I'm testing a hypothesis, typically called a null hypothesis. So these things are called null hypotheses. Null hypothesis, what we wish to test. And so in our example, the null hypothesis is going to be saying that the coin is fair. Okay, that's our null hypothesis. Okay. And I want to figure out a criterion. I'm going to flip this coin 3 times. So flip this coin 3 times. That's our experiment. So flip the coin. Okay, I'm going to flip the coin 3 times. I'm going to construct a criterion under which I'm going to reject this null hypothesis. I'm going to reject the null hypothesis. And remember, the null hypothesis is the coin is fair. I'm going to reject the null hypothesis if we get heads, 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 or tails, tails, tails. Okay? Now let's think about this. I'm given a distribution now. I know what happens if I assume the null hypothesis is true. So what we're going to do is we're going to say, so when are we going to reject the null hypothesis? So if we're going to reject the null hypothesis, let's think about what can happen on this distribution. I'm going to get heads, heads, heads exactly 1 time out of 8, right? That's 1 time out of 8. I'm going to get a heads, a tail, and a tail. How many? Or I can get a head, and a tail, or a tail, and a tail. Those are the only things going to happen. Again, tail, tail, tail only happens 1 time. And then heads, 1 heads happens 3 times. And then 2 heads happens 3 times also, right? So that's what my distribution looks like over here. That's my histogram, right? So in other words, 1/8 and then 1/8. So we're going to reject the null hypothesis 25% of the time. So we reject the null hypothesis in this test 25% of the time, which is 1/8 plus 1/8. Okay, we're going to fail to reject the null hypothesis. We failed to reject the null hypothesis. 75% of the time in this test, which is 3/8 plus 3/8. Okay? So one of 2 things can happen, of course, and so let's talk about this in general for hypothesis testing. So we're going to have these things, and so of course, what this is called, this 25%, this is rejecting the null hypothesis under the assumption that the null hypothesis is true. So in other words, I've rejected the null hypothesis as 25%. This, of course, is assuming null hypothesis is true. Okay, when I did this configuration, this histogram over here, I assumed that the coin was fair. So I have a 1/8 of a chance, a half times a half times a half of getting a head to head head. So the probability of heads, 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 given that the null is true, was 1/2 of the first coin. That's the probability of the heads for a fair coin, 1/2, and then 1/2. So I'm assuming the null hypothesis is true in order to make this histogram. So we reject the null hypothesis, assuming the null hypothesis is true 25% of the time. That's called the significance level, or a type 1 error. So here's the situation we have with hypothesis testing in general. So we can, if the null, so various things can happen. So the null hypothesis can be true. The null hypothesis can be false. We can reject the null hypothesis, or we can accept the null hypothesis. So we can reject it or we can accept it, and it can be true or false. And we have a little table over here. Okay. Let's fill in the table like that. Make it look a little bit pretty. There's our table over here. So if I reject the null hypothesis when the null hypothesis is true, this is called a type 1 error. A type 1 error. Because it's an error. If you reject it when it's true, type 1 error. So in this case, the probability of a type 1 error is going to be 25%. Okay? We accept the null hypothesis. If I accept the null hypothesis and the null hypothesis is false, that's also an error. That's called a type 2 error. We can only compute a type 2 error if I have an explicit, now of course, if the null hypothesis is false, the coin's not fair, I have no means of computing the probability because I'm not telling you what the alternative hypothesis is. There's no alternative hypothesis in this problem. If the opposite of the null hypothesis is the coin can be unfair, meaning the probability of heads could be a quarter, or it could be 3/8, or it could be 75%, or it could be 0.9, or it could be 0.999. I can only compute type 2 errors if I have an alternative hypothesis. Typically, we only compute null hypotheses or significance of the level. If I reject the null hypothesis when the null hypothesis is false, that also has a name. That's not an error. So these, of course, are errors. So that's an error. That's a type 1 error. That's a type 2 error. If I reject the null hypothesis when the null hypothesis is false, that's called the power of the test. So the power of the test is the complement, or 1 minus the probability of a type 2 error. So power is 1 minus the probability of a type 2 error. So in further videos, we'll see examples of doing hypothesis testing, but the key features are that you need to have a hypothesis about some parameter, namely, of course, here the probability of the coin is fair. You need to have a sample or a distribution, which you can actually look at, assuming the null hypothesis is true. And in certain cases, you'll need to find an alternative hypothesis that is an opposite, or some set that if the null hypothesis is not true, then the alternative hypothesis has to be true. Thank you very much.